Welcome back for another day of distance learning online. How does a tree get online? They log in. Log, get it? Logs, trees. All right. Solving absolute value equations. So yesterday we worked on graphing absolute value, which the graphs were V-shaped. Today we're going to solve absolute value equations. An important thing to remember as we solve is that absolute value is the distance from zero on the number line. So we're always looking to see how far away it is from zero. So when we're asked to solve the absolute value of x equals 3, we're really solving where are we 3 spots away from zero. Well, if I count 3 spots to the right, 1, 2, 3, that's going to be positive 3. But if I also count 3 spots to the left, 1, 2, 3, that is also a distance of 3 from 0. So we actually get two different solutions. We get a solution at negative 3, and we get a solution at positive 3. So if we're finding the absolute value of x equals 3, x can either equal negative 3, or x can equal positive 3. We're going to get up to 2 solutions. Same idea with 6. If our distance is 6 spots away, we can go 6 to the right of 0, which would be positive 6. Or we could go 6 to the left of 0, which would be negative 6. And we would get a solution at negative 6 and a solution at positive 6. So x equals negative 6, x equals positive 6. If I was to plug this into the equation, the absolute value of negative 6 is 6, because negative 6 is 6 spots away from 0. Same thing, if we plug in 6, it works, because 6 is also 6 spots from 0. If our distance is 1, well, then we're either at positive 1 or negative 1. Right? Those both have 1 spot away from 0, 1 spot away from 0, so they both have a distance of 1. But what about if our distance from 0 is 0? How can we be no spots away from 0? Well, if we're not any spots away from 0, we are at 0. So how many solutions is that? Well, that's only one solution. Our only solution is x equals 0. That's the only number that if we plug it in, we'll have an absolute value of 0. So we usually get 2 solutions, but it is possible to get one solution if our absolute value is 0. Now, what if our absolute value is negative? So let's think about it. Absolute value is distance from 0. And yesterday we talked about distance never being negative, right? I'm not going to go on a walk for negative 100 yards, right? We're going to go 100 yards. So if distance is always positive, when will our distance be negative 3? Well, if our distance is positive, when will our distance be a negative? Never! So we cannot have an absolute value or a distance that is equal to a negative number. So this would be no solution. All right. Now we're going to up the difficulty level a little bit. Our bars mean absolute value, and the absolute value means distance. So our distance of this equation, or this expression, is 11. How can we have a distance of 11? Well, we can either be at positive 11 or we can be at negative 11. But we also have this stuff going on right here too. So I'm going to set up 2 separate equations. My first equation is going to be, I want my absolute value to be negative 11, because that would be a distance of 11. Or I'm going to set it up so that my distance is positive 11. And now I get 2 separate problems. So again, if our distance is 11, we're either negative 11 or positive 11. And then whatever's in here is what we're setting equal to the negative 11 and the positive 11. Once we set that up, we just solve each problem. Add 5 to both sides. Divide by 2. And one of our solutions is -3. And that doesn't mean -3 is 11 spots away from 0. It means that if we plug -3 into the equation, we would get 2 times -3 is -6. And -6 minus 5 is -11. And what's the absolute value of -11? It is 11. So it works. We're going to do the same thing on this one. We're going to add 5. To get x alone, we're going to divide by 2. And we get that our other solution is x equals 8. So we have 2 possible solutions, -3, +8. How can we check our solution? Plug it in, plug it in. If we plug in 8, 2 times 8 is 16. 16 minus 5 is 11. And what's the absolute value of 11? It is 11. All right. So same idea. It doesn't matter if our bars are on the right or the left. If our distance is 15, we're going to set up 2 equations. Whatever's inside the bars, 3x minus 6, we're going to set it equal to the negative, so -15, or we will set it equal to the positive 15. Because we know if our absolute value is 15, we're either at -15 or +15. Once we set that up, we can go ahead and solve. Add 6 to both sides. Divide by 3. And x equals -3. You have to be careful because some people, once they get their first answer, they automatically want to say the second one is +3. But as we're going to find out, it's not always just a number and its opposite. This one, if we add 6 to both sides, we get 3x equals 21. Divide by 3, and our other solution is actually +7. Again, what makes those solutions is that if we plug those numbers in, they make the equation true. 3 times -3 is -9. -9 minus 6 is -15. And what's the absolute value of -15? It is 15. -15 is 15 spots from 0. So we got that absolute value to equal 15. Same thing, if we plug in 7, we end up getting 21 minus 6, which is +15. And we know that the absolute value of +15 is 15. All right, so several more examples, just so you can get the process down. I find that the more you see it, the more you kind of pick up the various patterns. So this first one, my distance is 3. So I'm going to set the x plus 7. I'm going to set it equal to -3. And then I'm also going to set it equal to +3. Once we do that, we solve the equation. X equals -10. And then on this one, x equals -4. Again, anytime our absolute value equals a positive number, we're going to get 2 solutions. Same thing here, we're going to set up 2 problems. X minus 9 equals -12, or x minus 9 equals +12, because we know that both -12 and +12 will have an absolute value of 12. We can then solve it. Add 9. X equals -3. Add 9. X equals 21. Both of those will work. I can double check by plugging them in. And if I plug this in, I get -12, which has an absolute value of 12. And if I plug this one in, I get +12, which also has an absolute value of 12. Now this one is where we could definitely get tricked. Some people might start setting it up and they might do 3x plus 7 equals -8 and 3x plus 7 equals +8. But I'm going to say, don't do that. The answer is no solution. Or no solutions. Why does this one not have any solutions? Well, the bars mean the distance from 0. And when will our distance be negative? Never. We're not going to have a negative distance. So no matter what numbers we plug in here, we will never get our absolute value to be a negative 8. Because even if this was negative 8, what's the absolute value of negative 8? Positive 8, not negative. So we will not be able to get any solutions. However, if it's equal to 0, we're going to get one solution. I can start setting up my two problems. But the thing is, my first one, I would do 2x plus 3 equals negative 0. Is there such thing as negative 0? No. So we're not going to solve that. That makes no sense. But we can do 2x plus 3 equals 0 and solve that. That will work. Subtract 3 on both sides. Divide by 2. And we get x equals negative 3 halves, which we could also rewrite as x equals negative 1.5. Or you can leave it as negative 3 halves, same thing. Okay, the next step, or the next difficulty level, as we keep moving along, is now we have the absolute value, but there's something outside of the bars. So this one has a 3 that's outside. This one has a 2 that's outside, but it also has a minus 11. In order to solve these, the first thing you have to do is get the bars alone. Get the absolute value by itself. So I need to find a way to get rid of 3. Well, what is this 3 doing to the bars? It's multiplying. So to undo multiplication, I can simply divide. And what I divide one side by, I have to divide the other by the same thing. And that gives me the absolute value of x minus 2 equals 4. And now we're right back to the problems we did on the slide before. We have an absolute value equal to 4. If our absolute value is 4, we're either at negative 4 or positive 4. So we do x minus 2 equals negative 4. Or we can also do x minus 2 equals positive 4, and we'll get the two solutions that work. Add 2 to both sides, x equals negative 2. Add 2 to both sides, x equals 6. So again, two possible solutions. If I plug them in, they work. Now this one, we do need to get rid of this 2, but if we divide by 2, we'd also have to divide the negative 11 by 2, which is going to give me a fraction, which is fine. But just like when we solve a regular equation, we always get rid of addition or subtraction before we get rid of multiplication. So the first thing I'm going to do to get the bars alone is move this negative 11. So to do that, I'm going to add 11 to both sides, which gives me 2 times the absolute value of x plus 5 equals 8. I still need to get rid of this before I break up into my two problems, because I have to have the bars alone before we break it into two problems. So I'm going to divide by 2. Absolute value of x plus 5 now equals 4. And now we're where we want to be. We have that the distance is 4. So if our distance is 4, we know that x plus 5 is either equal to negative 4 or x plus 5 is equal to positive 4. We can solve both problems. X equals negative 9, or subtract 5, x equals negative 1. So again, before you split up into your two problems, what do you have to do? You have to get the bars alone. You have to get rid of anything that's outside of the absolute value. All right, lots of practice, but that's good. Same thing, this is outside the bars. So before we set up our two problems, we need to move the 16, which gives us an absolute value of x equal to positive 16. So now I can set what's inside equal to negative 16, and I can set it equal to positive 16. And hey, there's no more work. X is by itself. Our solutions are negative 16 and positive 16. Negative 16 and positive 16. We could also call that plus or minus 16. Hey, that's kind of like what we did a while back. All right, next example. Can I split it into my two problems yet? No, I need to get rid of the 6, so I'm going to subtract 6 on both sides, which gives me 17 equals absolute value of x minus 8. If my distance is 17, that means I'm either at negative 17 or I am at positive 17. And then we solve both problems. Add 8, negative 9, and add 8, 25. So again, most of these problems we get 2 solutions as long as our bars equal a positive number. I think it's kind of overkill if I keep doing these, so I'm going to move on. Now, this is one we did actually earlier in the lesson. Let's see if you were able to pay attention on this. What is our solution to the absolute value of 3x plus 7 equals negative 8? No solution! Why is it no solutions? Because our distance can never equal a negative number. Now, one type of problem I'm going to add in here, because I don't know that I have it in this lesson. I might have something like this. And you might look at that and go, oh, it's equal to a negative number. It has no solutions. Well, this one actually does have solutions. And let's talk about why, and hopefully it'll make sense. In order for me to set up my 2 problems, what do I have to do first? I have to get the bars alone. So even though this is a negative 2 right here, once we add 6 to both sides, is this still going to be a negative number? No, it's going to be positive 4. So we can have an absolute value that's equal to a positive 4 because our distance can be positive. So we could split up our 2 problems. X plus 2 equals negative 4. X plus 2 equals positive 4. And we get our 2 solutions of negative 6 and positive 2. So again, just something to look out for. If there's a negative in the problem, it doesn't necessarily mean it's no solution. You have to get the bars alone. And if the bars equal a positive, we actually do have solutions. Now, if we had moved everything over and this was a negative 4, then we'd have no solutions. All right, so in conclusion, always get the absolute value part alone first. If there's anything outside of the bars, move those to the other side. If the absolute value part is a negative number, so if it says absolute value of x equals negative 5, you get no solution. If the absolute value part is equal to 0, then that means we're going to get 1 solution. So we just solve the problem equal to 0 and we get our solution. But majority of the problems, we're going to have the absolute value equal to a positive number. And if it's equal to a positive number, we have 2 different ways to be that distance from 0. We could either be at the negative of the number or the positive of the number. So we would get 2 solutions. In that case, we're going to follow these steps here. We're going to split the problem into 2 separate equations, where one is equal to the positive number and one is equal to the negative, and then you solve both equations. So hopefully you saw that enough times in the lesson today that those steps are making sense. We will practice this again a little bit tomorrow and then again on the review day as well. So finally, why exactly do most absolute value equations have 2 solutions? Well, there are 2 different ways to be the same distance from 0. For example, if our distance is 5, the 2 ways we can have a distance of 5 from 0 are to be at -5 or to be at +5. Both of those numbers have a distance of 5 from 0. What is the only time you get one solution? Well, the only time you get one solution is if your bars, doesn't matter what's inside the bars, I'll just put X for now. If your bars are equal to 0, that's when you're going to get one solution. And then when do you get no solutions? Well, that's if our absolute value is equal to a negative. And why would we get no solutions? Because our distance will never be negative. Right? Our absolute value is our distance from 0. Our distance will never be negative because distance is a positive quantity. And ladies and gentlemen, that is all for today. Hope you have a great day.